Good afternoon, everyone, and a very warm welcome, especially to our friends joining us from ACM student chapters across India. For those meeting us for the first time, ACM-VIT is the ACM student chapter at Vellore Institute of Technology and one of the most active technical communities on campus. Through events like Code to Create, Cryptic Hunt, and Reverse Coding, and student built platforms like Exam Cooker and Unipool, and the very one you're using right now, Conclave, we live by a simple belief. The best way to learn computing is to build. Working alongside us is ACMW, our sister chapter dedicated to celebrating and empowering women in computing. And none of this would be possible without the constant guidance of our faculty coordinator, Dr. Aswani Kumar Cherkuri. Today, we're privileged to host a session under the ACM Distinguished Speaker Program, which brings some of the finest minds in computing to communities like ours. And the theme couldn't be more timely. Everyone uses AI today, but few know what it takes to build it. That's exactly what our hands on workshop, Building Advanced AI Applications and Agents in 1 hour, will explore. Guiding us is someone who has spent over a decade turning research into working systems. Dr. Mehdi Bahrami, Senior Research Manager at Fujitsu, a senior member of both ACM and IEEE, inventor of over 34 US patents, and recipient of the 2024 IEEE Outstanding Engineer Award. Dr. Bahrami works at the intersection of machine learning and NLP. Dr. Bahrami, thank you so much for joining us today. The stage is all yours, sir.
Thank you so much. Thank you. You can hear me now?
Yes, sir, we can hear you.
All right. Thank you so much for joining this session. My name is Mehdi Bahrami. I'm going to present building advanced AI application and agent. So hopefully within like 30 minutes we will finish the structure and understanding of the foundation, and the rest like 20 minutes or 15 minutes we will have a hands-on workshop. So in order to actually proceed, uh, I would prefer everyone download the slide or open the slide online. So if you scan this QR code, you should be able to access and then click on the slide page and then click on today's slide. So you would be directly when you click on when we discuss about some links, so you will be able to follow these instructions. So the hands-on session also is require API key. So when you want to do the actual get your hand dirty on building your own agent, so I would recommend just using the XAI Grok. It might have some promotion, or it might need to add some amount credit to in order to try. But the alternative option also, you have a Grok inference, and also you can use the local LLMs if you have access. So those are like Olama or LLM Studio if you are familiar. If not familiar, you just try to use the any API. So um, to give you introduction, we are part of the ACM, the team here that handle and arrange this beautiful meeting and the session. Um, so we are like around 100,000 members around the world for more than 170 countries. ACM does have too many activities in computer science, electrical engineering, similar to IEEE. So we part of like the community, this huge community. I would suggest you to contribute. So for example, currently a student chapter here arranged this meeting, and we gather all together and discuss agentic AI. So there are different field, different activity like a computing resources. If you need all those activity, you can utilize ACM. So I would recommend you to be in touch with this ACM chapter. That would be a starting point for you. I'm also part of the Fujitsu R&D team. So in R&D team, we develop the research and we deliver the technology to customers, and the business units handle communication with customers. So we are purely focusing on how to build the technology and how we build AI agentic, and as well as how they interact with the different technology in terms of the agentic development currently. We do have internship, we do have different opportunities, so feel free to check out the Fujitsu research group as well. We do have in India also Fujitsu research. So you might, if you are interested in joining as an intern, so you may take a look to the Fujitsu research India. So in this session, we will review background of the transformer, LLMs, and AI agent. And the rest of the session would be a quick hands-on session, so you will be able to build your own. Um, so let me get us started by explaining that what is AI agent. So AI agent, there are different definitions. If you ask different people, they might answer you a different way. So AI agent is a system that try to fulfill a set of goal in a complex dynamic environment. That was the definition of the Patty Mays in 1994 defined, and as well as like a kind of another one you called like a social um, that let the emerge of from the action and intelligence of the individual agents. So so there is a lot of definition about the agentic AI. Those are also foundation of the agents that define much earlier than these days we are discussing about AI agent and how AI agent works. So AI agent is actually a system that allow you to look at the machine, perceive the content, understand the world, an environment, and take action. So you have some sort of observation, and then you have some sort of action. So unlike the traditional software application that follow predefined rule, so for example, when you create a software application, we regularly say if the user click on this option, if the user do something uh, process like this kind of content, if user enter this type of input. So there are a lot of conditions that we build based on the if then else. Those are like actually generate the algorithm and then the flowchart. So you end up with algorithm design, how to build a software application, how to make a condition. So those are definition of the traditional software application. But in the agentic AI, we don't define hard rule. So we're looking into the system that actually will be able to recognize the system, user inquiry, understand the word, and communicate with the user. So how the AI agent perceive and interact with their environment. So there are different ways to do this process. So one way is that we can have a tools such as function call, API call. We can have a sensor. So for example, in robotic, you might use the different sensors, or in IoT devices, you might look at the data as a, for example, temperature, how much light we have, how much wind we have. So those are like a sensor that you can capture, or a camera, you can record a video or record a snapshot, and then fit into the model. So then there are different also inputs. So you could get a text, you could get an audio, you could get a robotic arm, and then do some type of action on the environment. So a successful agent actually help you to understand the perception action. Loop is the key to agent behavior. So you do the repeated action in the loop. So you sense the environment, you understand the environment, and you do some action. So why actually, as you know, there we discussed about there is a definition in 1994 about AI agent, but why now we are discussing the AI agent? What happened now? We do have the AI agent and agentic AI. So this is come from the advancement in two categories. One is large language model introduction that would include also vision language model. So those are like a kind of foundation model that not only do some specific tasks, they are able to communicate with the human, they are able to understand the different words, and they can provide some context how to deal with this complex environment. And second one is parallel computing. So the parallel computing GPU now this day advancement help us to move much faster utilizing the LLM. So these two help us to understand the world much better, make a decision much better. So that's the reason now we have a agentic AI we're discussing today. But the definition is back to 1990s that define what is the AI agent and how they communicate different AI agents together. So those are definition very old, and there are a lot of paper publications. There are a lot of effort on agentic AI in that era. But now, because of these two advancements, we are able to build the different advanced system that understand the dynamic environment. So let's focus on the first category, LLM. So let's see what actually does, how it works, the LLM. So when you have a text, this text you want to provide as an input to the computer. But how you can do it? What is the title? For example, let's say there is a text. What is the title of the event at ACM San Francisco Bay Area chapter? So this text cannot understand the computer, right? So we need to generate some understanding. So let's first put the text as a different color coding. So for example, what is the title of? So why we do the color coding? Because we want to make it very understandable to the computer. So we want to convert each alphabet, each character to a digital. So we can actually do this part like a kind of utilizing, let's say, W, H, A, T separately. So for example, we can assign 0 to W, we can assign 1 to H, we can assign 2 to A, assign 3 to T. But that's make a problem because will be huge number. So in order to have a very complex and repeated context that we can always replace the data, so we can generate like this. We can create the what as a one number, let's say 3923 is correspond to 374. So which means if later we see the is and one blank space, we always keep it as a 374. So now we convert everything to digit. Now the goal is to understand how this digit works, right? So I would ask you to click on this link in page 6. Once you click, I want you to write something here. This is a test. And once you do, you will be see the color coding on the top. That's what we call a token. So here we have a 4 different token, 4 pieces of this context. And then you have a corresponding text here that converted to digit. So now if I repeat again a space is, you can see again 374, 374. Now let's put comma is. You can see the number is changed. So I want you repeat the same process. Everyone has access to the slide, or anyone has an issue with the slide. Cameron, someone from the ACM team confirmed that you would be able to access the slide and open the link.
Yes, sir, we're able to access it and open the link.
Okay, cool, cool. So now, basically, what you are doing is a one of the model. So I want you switch the different model. For example, GPT 3.5. So which means how GPT 3.5 split the data into the different pieces and convert to the data. So I want you to try the different models. Those are basically, even these tokens that we generate somehow is already trained to optimize the best way to generate the number and make it more complex number. So that's a goal for optimization of the, we call it tokenizer, that convert the text to the token. All right. So now you understand how you convert the text to the number. So now what you will be do, you will be give the rather than one single text. You can convert the whole book. You can convert all Wikipedia page. You can convert everything to a number, right? So now you can, rather than just simple, this is a test, you can copy paste the whole book in that text box and you can get a number. Once you get a number, you remove the last piece. Let's say, for example, 279, the last number, and you give to the black box model. This is assume that there is a black box. You fit this number and say what is the next number. So the next number initially tell you a random number. Let's say give you 1. And then you say, oh, you have an incorrect prediction. It should be 279. And you are 278 different. So then you give feedback to the model is incorrect, how to correct itself. So next time try this, we call it loss, decrease. So then now going doing better job, predicting better number. So what does mean this black box now? Once you click on this link in page 7, this is the call transformer model. This transformer model, you can see the GPT model, GPT Nano by default. So you can zoom in. You can see here, this is the number text you converted to the token, and token passed to the network. And then do a lot of this computation. Once this computation done, at the end, predict the number. So now I want you to try the different model here. So if you click on different model, you will see how network, as we move forward, more complex computation happen to the same number. So now when we say a model has a more parameter, means has a lot of this type of boxes that get an input and then multiply to those boxes which knob to generate the final output. So if you click on the Nano GPT and you can zoom out and then goes to the last piece, you can zoom in now, and then it shows that how the next layer, the final output, generate the result, predict the number. So when we say a model has a 9 billion parameter, means it does, after training all this computation, 9 billion knob adjusted based on whatever input you give You basically multiply to those knobs, and then you get a prediction of the next token. That's how the model works. So now if you see, say, oh, there is a model newly introduced is 27B, which means 27 billion parameter. 27 billion make a decision to just predict the next token. So as you increase that one, it shows that the performance also improve. You have a better prediction. So all these phases, basically the model is called pre-training phase, that you give the textbook, you give it general information, and it learn all those primitive information. And then you can fine tune it based on your task. For example, you want to understand sentiment analysis. You want to do the different process. After all this process, you have a two access to the model. Model regularly two type. One type is that you pre-train model, but you not publish to anyone. You utilize it inside, for example, your community, your company. For example, OpenAI for ChatGPT, right? Those are closed model, which means the model parameter is not shared for everyone. Some model exists, you can download those model parameter. One of the places that you can download is called Hugging Face. And then you download the model, and then you will be able to execute. If you have a GPU, you can run that model on your machine. If you don't have a GPU, you can run it still on your CPU machine, even on your laptop this day. Some framework like on a slot. So how it perform, how it compute and generate better result each time in this recursive. It's called back propagation, which means you give the data and you hide the one piece of the information, one token, and you ask the model, what was the issue? How much error I have? And then you return the response, say, this amount you have an error. That we call it back propagation. And that it shows that if you repeat it multiple times, let's say you 10 times you feed the model the same book, and then after the 10 times it aims to understand that book. There are some like a kind of question that why did, if the model are able to fix the like a kind of answer a lot of complex question like a math Olympiad question, but they are not able to, for example, answer how many are in a strawberry. Those are come from the very foundation problem in the large language model, how they process the content, not because of how they thinking. So let me give you an example. For example, if you see the strawberry, you put in that tokenizer, and then a strawberry come up with the three different tokens. So these three tokens. So now if you ask the model what are, how many are, there is no R token here, right? So in order to resolve that, some model they came up with some idea that split the task and explain the task. Let's say rather than a strawberry, put it RAWBE. So once you copy this and put it in the tokenizer, so then you will be see R would be one token, A would be one token, W would be one token. So now it can answer, say, how many are in a strawberry. So similar task. So when you're thinking, you need to think about, is it actually hurting the foundation of the LLMs or not? If something hurting the foundation LLM, then you need to change your task accordingly to better have a better performance. Anyway, how the current model resolve this issue by decomposing this question into the multiple text and make it more explanation. So then we'll be able to access and answer this type of question. And also some model, even they fine tune to resolve this type of issue, the foundation issue. So what make AI agent unique compared to LLMs? So ideally, LLM and AI agent, they want to do the same task. They want to utilize the tools So for example, access to the camera, access to the sensor, interact with APIs. They want to do the planning, they want to do the reasoning. All of them, they are goal of the LLM. But why we this day we are using agent on top of the LLM? Because LLM have a not exact good performance. So then we need to utilize on the top of LLM the AI agent to perform better. So they let them to utilize the tool, planning, reasoning, and iteration multiple times. So rather than just tell to LLM one time do something, and now we want to put it in the loop until resolve the issue. And also we want to have a collaboration between different LLMs to communicate with each other, right? How to discuss some matter between each other, how to make a conclusion. So all of them goes to the, we need to utilize the AI agent. And also self-improvement test time. So rather than, let's say, you want to improve the performance, prepare the model very good performance, you want to do it during the inference. What does mean during the inference? Which means you um, you run the model and let all the student at the same time submit their task, and then the agent aims to learn from all the students. So when you submit the task, that's we call it inference time, not training phase. So during the inference, then it will be able to communicate. So that's the reason. So ideally in future, all this area could be potentially goes inside the LLM. So then we don't need AI agent at all. But until we don't have the advancement much on LLM, then we need to create the AI agent. There are different approach. For example, how to improve the performance. You can do the self-supervised fine-tuning, which means you provide the label data and then you do the performance improvement. For example, I want to decide score the grade, for example, for the student assignment. So I can look at the historical data of the how graded, for example, based on the math you provide, and then you provide the grade, as well as you can provide the feedback. Those are label data. Sometimes we can utilize is called RLHF. RLHF means reinforcement learning from human feedback. What does it mean? It means you provide the model, say, okay, you this is the task. You will be execute this task, and then you will be return the response. And I will give you evaluation. For example, math. I can tell you, you you try that approach. It didn't work. I give you a score between 0 and 1. And once based on the feedback, you can improve the performance of the model. One of the popular one is a DeepSeek that designed on top of SFT to basically automatically improve the performance, and it shows that, for example, in some cases it can improve. The RLHF and reinforcement learning is not new. So in 2017, a paper published that shows that how actually you can run the AlphaGo game. So for example, this one is a human expert, the dash line. And then you provide some label data. Label data let the model to learn about, you can see how much learn until below the expert level. That's a label data. So it's not let to go above the supervised learning, goes behind the expert level. But reinforcement learning, it aims to learn and then go advance and then increase the performance above the expert level, which means expert never see. One example, I want you to look at this video that shows that when there was a movement that is called Move 37, that actually human was surprised, that comes from this layer above the expert. And also it shows that this paper that they can also decrease the performance. There are different ways to evaluate LLMs. So, for example, you can look at the leaderboard for LLM. There are a bunch of leaderboard exists for LLM to evaluate. There are several benchmarks. This is one example. Actually, this one almost retired. So now let's build an advanced AI application. So today we're going to use the small agent. A small agent is basically the name come from very less than 1,000 line of the code and is open source. So you can see actually the code as well by Hugging Face. So we're going to use the small agent. So how it works? So there are different ways to build the agent. One way is that you have an agent one step, you provide the text, and then you give to LLM, and the LLM utilize the tool call, for example, call some function, right? And then return response. So this is one simple way you create the AI agent. Another one that today we're going to do is an agent multi-step React. So what does mean? It means you provide the prompt, you provide the memory, it does have a prompt, and then you call the LLM, and then you tell to the LLM you have access, for example, to the web application. You can search on the web, and then it return response, final response, and if you will fill the user requirement, then it's end. Otherwise, it will be continue this process until resolve the issue. So there are different ways to build an AI agent. We can utilize the code, like a code generation. You can utilize JSON, for example, JSON file format you provide to LLM, and the text. So it should, in this paper shows that actually if you use the code is much more efficiently you can utilize. So rather than I say, uh, for example, open the page and search, I will write a code, Python code, to open a page and execute the same task. So it shows that if you provide the code as an input to the agent, it's much more successful. So today we're going to build this simple software application. User submit query to the agent, and agent make a decision, should I use the tool call or not? So there is a web browser, and then we have a LLM. So today we're going to use the Grok, XAI Grok API to handle the LLM part. We're going to use the DuckDuckGo open source web search engine that you can use the API as a tool call to the agent. And what we will do, we will develop this code, and then the agent can run. We can deploy it on the GitHub, or we can save on the disk this code and then publish it in the Hugging Face. So today I'm going to go to this direction, developer agent, and publish in the GitHub workspace. That would be your assignment as a homework to do this process. Simple. You just save the code, the what you generate the agent, and then you push it into the Hugging Face. And everyone can access your agent on the web. You can share the agent with other students as well. All right, so let's get started. So hopefully you have an API, but if you don't have an API, please, as much as possible, follow this instruction so you can try yourself, build the software application using this. And this is the link for the workshop. So first of all, I want you click on this link, everyone. Once you click on this link, please fork this repository. So click on the fork. Once you click on the fork, basically what it does, you copy this code on your GitHub. So first you log into the GitHub and click on the fork. You have a copy of this repository. I want you next change this one to dev, development. Again, convert this .com to dev. This instruction also is noted here. Also, if you in the readme, sorry. So once you convert, so this is our step which we are doing. So if you miss something, go follow this step. So now, once you click on the dev, you can you click on the agent. There is a .env sample. And once you right click on this, select allow and rename it. Rename this to .env. You can click on this button. If you don't see it, this terminal, you can go to this hamburger menu, click on the terminal, new terminal. Once you open the terminal, and once you click on this blue button, continue working in GitHub code space. I can say, yes, continue working changes. Let me GitHub. You allow the permission. So you can see on the right hand bottom side showing some progress. So now it's asking here on the top, asking you wants to create a virtual machine. So I would select the 2-core 8 GB RAM. So it's a small machine to do this process over AI agent. What it does is rather than you have a one computer, you buy a computer and you run the code on that computer, you virtually create that computer. And then now we're going to run the code here. Again, if you miss some step, back to the README file and continue. So now, once you get it, we need to also get a API key. So you can see now, this is similar to Visual Studio Code. It will be open. So once you open the XAI API key, XAI console, then you can create API key. Feel free to get the API key. I will change it later. So I copy this API key back to this file and then to this code. So then open the agent. So we open the agents, paste the API key here. So don't worry, I will change the API key, but so you will be do the same thing. Are we on the same page, everyone? So again, I change that one to .dev. I open in the code space. Any question so far?
I have one question. Is the XAI a free API or is it paid? Can you hear me?
Go ahead, please.
So the XAI is a free API.
I'm not sure. Most often they provide some promotion.
Okay.
but XAI might not. Previously, XAI provides some promotion, and then you will be able to
Okay.
do that.
We can still use
But
Gemini's API.
now
This works. Yeah.
Gemini, because if there is a Gemini, then you need to change the code to
Oh,
understand the Gemini. But I would
okay.
say if you have a Gemini access in the chat on the right hand side, I would suggest you do this process. Say, add the Gemini API to the agent. That's another way.
Yeah. Okay. Okay. Thank you.
Currently, we don't have Gemini here, but is easily should be able to. For example, in the chat, I can say, add Gemini. No, here you can add the content here. API. Once it's added, then you can update it.
Okay.
So let me like code the space a little bit. Get messy here. Let me refresh it. So what we are doing currently, dot environment, you put the API key. Currently XAI. You can use the Grok. Grok actually give the free trial. So you can utilize the Grok. Different, this Grok is a with K, this one is a with Q. So if you Google Grok, so let me remove this code space and redo it again. So once you want to remove, you can go to the code space. And then if there is a code space, you can remove the code space. There is another option you can do actually when you are here. You can see the code space associated to this machine. So I can kill this and I can kill this. So don't forget to remove this code space once you're done. So let me copy this and repeat the same process. So I'm going to build the code environment again, the process, and then we have this. So let me open it in the code space. So now again asking me how many GPU core. We don't need GPU on this machine because we are using API. Anyone has a question?
No, you can continue.
All right. So now again, what it does now is automatically will be recognized there is a Python here and will be build the Python in this virtual machine. So again, I right click on this. It's automatically removing the file here. That's causing the problem because it's syncing. So you can see it's a start in installing the Python. So I would paste the environment here. So once it's done in installing the Python, then we're going to, okay, it's done. We're going to run the setup. You just type ./setup.sh. It's going to install all the packages that require for this software application. Again, we just update the agent.env to API key. So I suggest you, if you want to use the free trial from Grok, as I know previously they had a Grok free trial, so you can try that one as well. And then if you have a question, you can ask question here also. Or if you need to update their code. For example, you want to use different API. So for example, you want to say, I'm using K3. So you can say add new connection. So you could add this way. So once it's set up, now let's run it. So ./run. Again, if you miss any step, all of them in the README, you should be able to see, but I'm kind of, it's not syncing. Okay. So this is a README. So you should be able to see actually what step we are doing. So once you start, then you can go to the port. You can open this page. If you right click here, you can make it public, and it will be able, you will be able to share with other people. So you can share with other students. So now it's opening. So what it does is basically we give the AI, the model, currently we're using the XAI. So for example, we can say who is the president, right? I think it's old version I'm using. But what it does, it will be execute. So it will be, when you say who is the president, the user submit the query. So the agent will be submitted to the LLM. But before submitting to LLM, it say you have access to web browser. So what it does is generating the code gathered by agent, and then the code say search president on the web, and then it's return the response provide to the agent, and then resubmit to LLM, say this is the response, and then final answer would be back to the user. So once you're done, then you will be able to see the trace on this line of the code. But I think the one file here has been removed from this, but it should be executed. I have to redo the process again. So now, once you do this process, you can actually, what you are doing is you deploying the code on the GitHub workspace. So I would like to ask you, you deploy it on the Hugging Face. the same code. So you don't need to change anything. You just deploy it on the Hugging Face. That would be your assignment. So then the final response would be like this. So you will be getting, for example, you enter question here. You will be have a step one, a step two. For example, it say go search for this ACM San Francisco Bay Area chapter. Once gather information, then provide to the LLM, and the LLM provide the final answer. So you will be able to see exact this output. So today we discuss only one agent, but recent study shows that you can do, for example, multiple agent. They do debate. They can do the interactive debate to get a better performance. So, for example, interactive debate shows the better performance improvement. Currently, we are also building the AI agent for the code. One example is a Kozuchi agent. So Kozuchi agent generate the code and execute the different tasks to resolve the issue. Feel free to check out our latest paper. If you click on this link, you will have access to the trajectory that generated by agent, and also you will have access to the source code. So recently we are releasing this Kozuchi agent publicly, and also the paper also available. Feel free to check out. If you have any question, reach out. We also look at the to into the AI agentic in terms of the bias. So this is another paper that we tackle how LLM can be biased. So for example, if you say the same, let's say two CV you provide to LLM, does it prefer woman uh, on the compared to the male? For example, for nursing, that shows that is possible. Some LLM do that. Or in computer science, LLM prefer male compared to the female or other gender. So kind of this type of bias exists because in our data there is a bias. So feel free to check out this paper that shows that how actually LLM you can detect and understand the bias in the system. So in conclusion, today we discussed about how to build AI agent. We understand what does mean LLM, how it works, and also we start building AI agent, a small AI agent that utilizing the LLM and execute the task utilizing the web. These are references for this slide. Feel free to reach out to me if you have any question, comment, or you want to participate in any other project. And also, my advice is that currently you're looking at a GitHub repository. You fork this GitHub repository. I would highly recommend you to look at, for example, this GitHub, how you can improve it. For example, how you can resolve the issue, how you can add more feature. For example, today, one audience asking about Gemini. Can you add the Gemini or, for example, Gemma into this feature accepted to add it to this AI agent? So those are would be contribution, and I highly recommend you to contribute to the open source community. It will be very highly visible in your future. You want to find a job, or you want to participate, you want to communicate, you want to have advancement. I would highly recommend you to do this process. I'm also open to any collaboration. First of all, thanks to Lavonia for the invitation, and feel free to reach me out if you feel there is something you want to discuss or you want to have a collaboration. Thank you so much for your attention. That's all for me. If you have any question, I would be happy to answer.
Do you think like building your own agent, like for example through this repository, would be more beneficial compared to like similar compared to using generalized agents, for example, like Cloud Code or Codex?
That's a good question. I would say depends. So, for example, sometimes your task is very narrow in your domain or a specific things, then it's better to utilize yours on the top of general models. But if there is a general task, so for example, you want to fix GitHub issue, those are general. So those general, you may use the publicly available.
So I was wondering what your thoughts are on switching from tokenization, like how it's done today, to something like Mamba, because like there's so many issues, like the strawberry example you brought up, or even with arithmetic calculations, where tokenization fumbles, and then we try to patch it up with extra training. So do you think redoing the fundamentals with these other things that have been researched about is a good way to go about it?
That's a good question. So I would say depends. So for example, diffusion model, they do the same task but the different way, right? So all of them they do the different way, but the question is sometimes you might need to do a specific task, sometimes you need to do the general task. Which model is better, which one use the different architecture might be better. So that would be depend to the task again. So I would say it's very hard these days to say, for example, one model can tell you everything. You know, so I would say, for example, sometimes you see there is some diffusion model that help you to do better for OCR or other tasks. You might end up with using that model. Or, for example, these strawberry cases might not appear in other like architecture, right? Because they're using the different methods. So those are depend what you want to do, what you want to achieve. I would say you will decide the architecture wise or model or even how much model parameter depend to your task. So for example, you there is a model like a 27B. There is a model 1 billion parameter, 4 billion parameter. The same model, the company or different company provide variety of the number of parameters. But if I want to put it on the camera, then it's better to be on the edge than a smaller model I would use. But if I want to put it performance on the top, so my high priority or my task is very high priority, I would use that one. So similarly, if you switch between the different models, I would say.
Head
Got
east,
it.
then turn right.
Any other question?
So there's a few questions on the chat.
Sure, go ahead, please.
One of
Can
them
you?
says, why don't we create a model with more and more parameters to make it the most efficient?
Sorry, could you repeat again the question?
So the question says that why don't we create more and more parameters, like models with more number of parameters to make them more efficient?
That's a very good question. The problem is that currently this is the trend. So these days, any you will see model as we move forward, we use the more parameters, and it shows that better performance. But the problem is that when you add more parameter, you need more data, and then you need more computation. That's a huge significant problem because, for example, you use 10 books, now you need 100 books, and then you will end up at some point still is under discussion where we are reaching to the top peak of the data, which means there is no more data exists that led to the model to learn. So increasing the parameter is good, but it's very expensive. So then you need a more iteration. Rather than 10 times you read the book, you need 100 times on larger number of the books you read, and then you compute. That's very expensive.
Got it, sir. So
So we have a
cost is the
we have
main
a
draw.
bunch of more questions. Yeah, sorry. We have a
Go
bunch
ahead,
more
please.
questions in the chat. Um,
Yeah, if someone
so
can
someone
read it
said,
because it
"How is an
shows my on my study
yep,
slide.
yep, yep. How is an AI agent built using an API different from an API wrapper?"
AI AI wrapper, you say?
Yeah, that's an AI wrapper. I'm not sure what the question means.
Um, it's not clear to me, but if the question is about you create the like a kind of basically everything is a wrapper, so you call it like if you call it wrapper is pretty much everything on top of like a kind of LLM. So you build a small harness on the top of LLM, or you might build up very complex case. Um, Depend what you wants to do. But I would say like a kind of all of them equivalent, and you may call it wrapper on top of that. We can have a one more question if you have.
Okay,
Sorry, couldn't
the
be
last
read.
question
Another
is
question.
the last question we have is when would you choose to use parameter efficient fine tuning methods like LoRa or QLoRa over full fine tuning?
That's a good question. So basically, if you have a like a kind of there is a two different things. One, resource. You have a, for example, enough resource to do the fine tuning, full fine tuning. Second one is how much data you have. If you have a small data that you do the label data you want to do, more likely it's better to utilize the LoRa and QLoRa. But if you have a lot of data enough and you have a resource, GPU resource, to do the full fine tuning, then you will go with the full fine tuning. Otherwise, if for example you have a small data, you do the full fine tuning on the big model, then it would be end up with overfitting that will be answered very good on your label data, but it doing very bad on unseen data. Thank you so much. Thank you for arranging this meeting. It was very great. And feel free to reach out on me in the LinkedIn. You can also email me. And also, I would appreciate if you can look at the GitHub repository. So I would ask you to run it in any way you try to grok or grok with Q using their promotion. So I would or run it locally. And then if you see any issue, feel free to add it and then submit a merge request.
Thank you so much, sir. I think we have a few words that Ishita would like to say. Ishita, are you here?
Sure. Thank you.
Yeah, yeah. Thank you so much, sir. That was genuinely very helpful. Thank you, Dr. Bahrami, for such an enriching session. I'm sure many of us are already itching to open our laptops and start building. Now, as we wrap up, our deepest gratitude to you, Dr. Mehdi Bahrami, for distilling over a decade of experience into a session as hands on as it was inspiring. Our sincere thanks to the ACM Distinguished Speaker Program for making this possible, and also to our faculty coordinator, Dr. Aswani Kumar Cherkuri, for his constant guidance. To our friends from ACM and ACMW chapters across India, our wonderful listeners, and the organizing committee of ACM-VIT and ACM-WVIT, thank you so much for making today a success. That brings us to the end of today's session. Thank you all and have a wonderful evening.
Thank you so much. A great team work. I
Thank you, sir.
appreciate
Thank you
it.
for coming.